My name is Motra Enoch, and we are going to revise together physics under the topic static equilibrium, solving specifically questions that comes under ladder problems. So the first question reads, state two conditions for a system to be in static equilibrium. So what you have to know is that static is something that is not moving. So for any system to be in static equilibrium, summation of vertical and horizontal forces must be equal to 0. Also, summation of talk about a certain point must be equal to what? 0. So we can start answering. So say solutions. So that is 1a, summation of vertical and horizontal forces must be equal to 0. That is summation of forces in x-axis is equals to 0. That is horizontal. Also, summation of vertical forces is equals to 0. That is the first condition for any system to be in equilibrium. The second one, that is summation of torque about a pivot must be equal to 0. That is summation of torque about pivot is equals to 0. So these are the two conditions that are necessary for any object to be in what? Static equilibrium. So we proceed to B, where they are saying a uniform ladder of length 5 meters and weight 400 Newton rests against a sloping vertical wall as shown in the figure 4.2. The inclination angle between the ladder and the floor, rough floor, is 53 degrees. First question, they are saying draw a free body diagram. So we go to B. So I'm going to extract this triangle. This is the ladder having the length of 5 meters. So a ladder leaning against the wall, 53 degrees, the length that was 5 meters. So what you have to understand is that the question is saying that this floor was rough. If the floor was rough, meaning there must be what? Friction force. Another thing is that this vertical wall was what? Sloping. They are saying sloping vertical wall simply means that the wall was what? Smooth, meaning there was no friction. So I'll say smooth wall. Now, how do you show the forces? So if this ladder hits the vertical walls, we are going to abide to the Newton's third law of equation, which is said that for every action there must be an equal and opposite reaction. If this ladder hits the wall, meaning the wall is going to produce an opposite force which must point toward this way vertically. So I'll say this would be the reaction force, and then I'm going to assume this is my point A B. And then apart from that, this same ladder hits the floor. So there must be a what? A reaction force going upward, which is a reaction at point A. Apart from that, as this ladder is slipping or is sliding this way, it is moving this way. Friction acts in such a way that it always opposes the motion of any object. So it is going to point toward positive x-axis, which is friction at point A. Apart from that, this same ladder adds weight. Now, the weight of the ladder always acts at the center. Why? Because the center of mass, the weight always is concentrated at the center. So there must be a weight force pointing toward the center, which is 400 Newton. So this is the free body diagram. Simply means that we have answered question A. B1, I mean. Apart from that, we can now proceed to the second question, where they say determine the reaction force from the floor and from the wall on the ladder and the static friction coefficient at the interface of the ladder with the floor that prevents the ladder from slipping. So what you are going to do is that you are going to abide to the conditions that make an object to be not static equilibrium. So let me just nab the what? The top part to create space. So I'll start with summation of forces in x-axis. So summation of forces in x-axis, so I'll assume going this way to be positive is equals to 0. So my friction force was going this way to the positive axis, so it will be Fa minus this reaction force that was opposing the motion of summation of forces in x-axis, which is Rb is equals to 0. So making Fa the subject of the formula is going to be Fa, this one is going to cross the equal sign to become the positive Rb. So you just pause like that, keep this equation. So from there, we move to summation of forces in y-axis. So summation of forces in y-axis is equals to 0. Going up, our assume to be positive. So I'm adding this reaction force pointing upwards, so that is Ra minus this 400 that was opposing the motion, minus 400 is equals to 0. So reaction force A is equals to, taking negative 400 crossing the equal sign to become positive. So 400 Newton. So that is what reaction force at A. Another thing, we need to go to the third condition, that is summation of torque about a fixed point. So in this case, I'm going to take point A to be my what? My pivot point. So I'll say summation of torque at point A is equals to 0. So what am I going to do here? We know that torque is calculated by force multiplied by perpendicular distance. That is the formula that I'm going to abide to. So I'm having this reaction force B which will be reaction force B multiplied by. So, before you even go further, you have to do this. This is my pivot point. So if let me take, for instance, I get this marker and then I apply a force. This is the reaction force going this way. So this marker is going to rotate anti-clockwise. So since it is rotating anti-clockwise, I'm going to add a negative this side. Now, I have to multiply with the perpendicular distance, the distance that is making 90 degrees. If this force is going this side, meaning if this force is moving in the x-axis like this, the only distance that can make it perpendicular is the vertical distance, so that when they meet here, they are going to form 90. So the distance that I'm going to consider is the height here, from there to there. So I have to calculate. So I'll extract a triangle here. So that is 53 degrees. And then we have been given to say from there to there, that is 5 meters. And then I'm looking for perpendicular distance. So here I'm having opposite and hypotenuse, that is sine, using SOHCAHTOA. So that is sine. My theta, that is 53 degrees, is equals to opposite, that is height, perpendicular distance, over hypotenuse, that is 5, over 1 cross multiplication. So that is sine 53 degrees times 5. So my height, what are you getting? Sine 53 times 5? 3.99. 3.99, like this also?
Yes.
So that is in meter. So this is the perpendicular distance that I'm going to multiply with the reaction force at B. So that is 3.99. So apart from that, I'm also having this force. Bear in mind to say that if you choose this point to be a pivot, this force and that force, they are going to cancel. Why? Because they are going to be multiplied by what? The distance, which is 0. So 0 times the reaction force at A, that is 0. 0 times the reaction force at A to be 0. So the only forces that I'm going to consider is the weight force and then the reaction force at what? At B. So from there, this force here 400, I'm going to get a marker, putting it at my pivot point. So if I press this 400 Newton downward, you are going to find that this marker will be moving what? Clockwise, which is positive. So that is positive 400 times what? Perpendicular distance. Now, if this force was acting at the center, this force was acting at the center, and we know to say from that point to that point, that is 5. So to get the distance from my pivot point to where the weight force was concentrated, if I divide this 5 by 2, I'm going to get 2.5 there, 2.5 there. So I have to extract the what? The triangle. This is a small triangle to find what perpendicular distance. If this force is going downward, the only distance that can make it perpendicular is the horizontal distance. So I'm looking for this distance. So I have to extract a small triangle. So that is a triangle that I'm having 53 degrees. From that point to the weight force, I'm having 2.5. And then that is x. So that is cos, that is adjacent, cos 53 degrees is equals to x over what? Hypotenuse, which is 2.5 over 1 cross multiplication, that is cos 53 degrees times 2.5. So when you multiply, what are you getting?
1.50.
1.50 meter. So this is my perpendicular distance that is going to be multiplied with what? Weight force. So then what? 1.5 degrees is equals to what? 0. So from there, it's just a matter of simplification. So here, if I multiply negative RB times 3.5, that is negative R, that is negative 3.99 RB plus 400 times 1.5, 600 is equals to 0. So from there, getting this number, crossing it, the equal sign to become what? Positive. That is 600 is equals to positive 3.99 RB over 3.99 over 3.99. So you cancel. So you are going to get RB is equals to what?
150.38.
150.38. That is 150.4 Newton as your RB. Now you have to say, you have to recall that FA is equals to RB, and then RB that is 150.4 Newtons. That is, these are the forces that were supposed to be there. Now, apart from that, what you are supposed to ensure or to make sure is that always find the summation of forces in x-axis, summation of what? Forces in y-axis, also summation of torque about a certain point. Now the question is saying, and the static friction coefficient, and we know to say, since friction was acting at FA at point A, meaning my friction force is equals to the coefficient of kinetic static friction times what? R at point A. So my friction force at A, that was 150.4 is equals to mu S times reaction force at A, that is 400. So dividing both sides by 400, you are going to get static friction of what? 0.37. So coefficient of static friction, it has no SI unit. So these are the required solutions that we are supposed to be at this question. So please, if you have found this video interesting, don't forget to subscribe for more videos. Thank you so much.